I can teach you code in Python in just 30 days, even if you've never written a single line of code before. How? Simple. In my 30-day Python using...
Okay, so we will be continuing with our binary search playlist. Now, this is the part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Make sure you check it out. So before starting, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we're going to solve today is finding out the median of two sorted arrays. Now this word is very important, sorted, because that is what will help us to solve this problem. Now you can be given two arrays of equal size. You can also be given two arrays of different size. Like in this example, you can see this array is of size 6 and it is sorted. This array is of size 4 and it is sorted. Now what you have to do is you have to find the median of these two sorted arrays. So what you have to do is you have to take both of those sorted arrays and you have to combine them. So if I combine them, what I get is 1, 2, 3, 3, 4, 6, 7, 10, 12, 15. What is the total number of elements? The total number of elements in this case is 10. Why? Because n1 was 6, n2 was 4. So the total number of elements is 10, right? So if I try to find out the median, can I find a median of 10 elements? I cannot. Why? Because if I stand over at 4, there are 4 elements on the left. There are 5 elements on the right. If I stand at 6, there are 5 elements on the left, 4 elements on the right. So there is no specific median, because median means on the left and on the right, there must be equal number of elements. Now this is not, in this case, this is like 5 and 4. They're not equal. So can I say the median will be somewhere between 4 and 6, because if I take somewhere between 4 and 6, on the left there are 5, on the right there are 5, which is equal. So I can say that the median is somewhere between 4 and 6. So it's like the middle of 4 and 6. So 4 plus 6 by 2. 5 is the median in this case. Now over here, the point to notice was the total number of elements was even. That is why it did not have a specific median. But what if I take this example? There's like 3 elements, there's like 2 elements. So what is the total number of elements? Can I say that the total number of elements in this case is 5? I can. So if I try to combine them in this time, what will I get? If I try to combine them, I'll get 1, 2, 3, 3, 4. If I ask you what is the median, can I say this is the median? I can. Why? Because there's like 2 elements on the left, there's like 2 elements on the right. Thereby the median is pretty simple, the midpoint. So in case of the total number of elements being odd, it's very simple. In case the total number of elements is even, I have to consider 2 elements, I have to take the middle of it. Got it? Now this is what we have to find. We have to find the median of 2 sorted arrays. So what is the first solution that you can think of? The extreme brute force that comes to my mind is, okay, 2 sorted arrays. Can I merge them into a third sorted array? If I merge them, then I know I can solve it afterwards. And the point to notice over here is both of them are sorted arrays. And you know how to merge 2 sorted arrays into one. We have done that in merge short, isn't it? So what I'll do is I'll stand at 1 and I'll stand at 2. And I'll try to take another third array and I'll try to put it over there. Will I take 1 or will I take 2? I'll take 1 because I'm trying to form a sorted array. So I'll take 1 and I'll move. Will I take 2 or will I take 3? I'll take 2 and I'll move. Will I take 3 or 3? I can take any one. I'll take 3 and move. Will I take 3 and 4? I'll take 3 and I'll move. Will I take 6 and 4? I'll take 4 and I'll move. Will I take 6 or 7? I'll take 6 and I'll move. Will I take 7 or 15? I'll take 7. I'll move. Will I take 10? Yes. Will I take 12? Yes. Will I take... After this, there's nothing. So whatever is left on the right, I'll just take it. So we have put 2 sorted arrays into the third one. Now what is the next step? The next step is to find out the median. Can I say if the total number of elements is even? I need to find 2 median elements. One is 4 and the other one is 6. And I need to basically add them and divide by 2 to get our median, right? And you know how to find it. The index is 0, 1, 2, 3, 4, 5. You need the 4th index and the 5th index. 5th index is nothing but 10 by 2 and the 4th index is nothing by 10 by 2 minus 1. So you get both the indexes and then you can do your job. I'll write that in code, but before that, let's look at the other example. In the other example, when you try to merge them, you'll get something as 1, 2, 3, 3, 4, and over here, the total number of elements is odd. And which index do you require? You straight away require this one, which is the 2nd index. Can I straight away write 5 by 2 and that will be the 2nd index and that will be my only median? I can, right? So this is how the brute force will be. So let's quickly write down the pseudocode. So what I've done is I've taken an array 3, which is an empty array. I've taken index I, which points to the so I'll keep on next to j. Basically add x. So some element which is like if just quite median plus the answer will be exactly the median will be, if I have to write, it's array 3, same code. The only minute difference is I'm typecasting over here because the answer will be in double, and if you do not typecast, these are integers, you might end up getting incorrect answers. So if you try to submit this, you'll get a partially accepted. Why? Because it's taking a lot of time. The total time taken over here will be, you're going through every element in both the arrays and you're putting them into a third array. So since you're going through every element, that's n1 plus n2 because that is the total number of elements. You're using a third array to store all the elements. So that's a big of n1 plus n2. Now this is giving you a time limit exceeded. Can we do better? The next better solution will be to optimize the space, and after that we'll try to work on this time limit exceeded. But as of now, can we optimize the space, like get rid of this third array? That is what we'll look forward to. So in the brute force solution, we were using an extra space. Why was that? Because I was using an array 3 where I was storing all the elements. But if I just think logically, do I need all the elements? The answer to that is no. If I can somehow just get 4 and 6 for this example, and then just divide them by 2, that's done. I don't need all the elements. Why am I storing all the elements? I just need 4 and 6. In this particular example, I just need 3. I don't need all the elements. So let's focus on picking up 4 and 6 only, or let's focus on picking up 3 only. So when you're doing the algorithm, if you remember, we checked for n's value at the end. If it was odd, we did the computation. If it was even, we did the computation at the end. But before that, we merged them together. So let's have some observations. The total number of elements are 10. At the 4th index, I have the first index 1 element, At the fifth index, I have the index 2 element. And if it is even, I'm adding them up and dividing it by 2. So let's call index 1 as 4 because I in the fourth index element and index 2 as 5. I in the fifth index element, which is called as element 1 and element 2. And what is these values? If you just do total by 2, you'll get index 2. And if you just subtract it by 1, you'll get the index 4. So it's basically n by 2 and n by 2 minus 1. And this is index 1 and this is index 2. In this case, if you divide by 2, you will get index 2 because the formulas are similar. I want to keep the same formula so that I don't have to write repetitive code. So element 2. So what I'll try to do is I'll try to find index 1 and index 2. In case n is even, I take both of these elements, sum and divide by 2. In case the element is odd, I will have index 1 and element 1, but I'll discard it, and I'll just take element 2. That will be my answer. So let's quickly try to merge it, and in the process, try to find the fourth index element, and in the process, try to find the fifth index element. That is index 1 and index 2. So we will not be merging it.
Highest paid job in 2026 is not of product manager, is not of software developer, and is not of data analyst as well. The highest paid job in 2026 is of AI tools and AI automation.
And let's call the first index as count 0. Count refers to the first index, which is 0. How did we merge? We started at 1 and we started at 2. Hypothetically think, which one will be your 0th index guy? 1. 1 will be a 0th index guy, right? Let's move to 3. And that means the count moves to first. You're looking for your first index guy, and that's 2. Let's take 2, and now let's move this and move the count to the second index. Now you're looking for your third index guy. Who is your third index guy? 3. Let's take 3 and move count to 3. Now what are you looking for? You're looking for your third index guy, and the third index guy will be 3. So let's take 3 and move the count to the fourth index. Here comes the twist. Your count is looking for an index which you need. So which one will it be? 4 or 6? It says 4 because of the comparison. So I take 4 and I say I got my element 1 because I was looking for the fourth index guy. So I got my element. And after that I'll move. Now the count will move to the fifth index because I'm looking for the fifth index guy. Again, it's happening hypothetically. You're not storing these elements. You're just not storing. You're just playing with the pointers. You just move the pointers. The count is at 5th and he says 6 is the guy, and you store the 6th. Just store the 6th. And then you move the count and you keep on doing your process. And if you figured out both the elements, the job is done. And the answer will be element 1 plus element 2 by 2. And that's it. In case n was odd, the answer will be element 2. You would have stored element 1, but the answer will be element 2. Right? Got it? And so let's quickly get back into the code editor, because if I try to write down the code in the iPad, it's going to be super messy. And since we're just using increment operators and while loops, I think the C++, Java and all the versions will be similar, so you'll be understanding it. Doesn't matter which language you follow. So what I am doing is at first making sure I take n1, n2 and initialize I and j pointers and get the value of n. After that, we know the values of index 2 will be half of the total length and index 1 will be 1 before that. Simple. And we are keeping the index tracker. This is the tracker. The count is the tracker, which is basically n is even. I take both of these elements. The total number of elements are 10. At the fourth index, I have the first index 1 element. At the fifth index, I have the index 2 element. And if it is even, I'm adding them up and dividing it by 2. So let's call index 1 as 4 because I in the fourth index element and index 2 as 5. I in the fifth index element, which is called as element 1 and element 2. And what is these values? If you just do total by 2, you'll get index 2. And if you just subtract it by 1, you'll get the index 4. So it's basically n by 2 and n by 2 minus 1. And this is index 1 and this is index 2. Quite simple. In this case, if you divide by 2, you will get index 2 because the formulas are similar. I want to keep the same formula so that I don't have to write repetitive code. So element 2. So what I'll try to do is I'll try to find index 1 and index 2. In case n is even, I take both of these elements, sum and divide by 2. In case the element is odd, I will have index 1 and element 1, but I'll discard it and I'll just take element 2. That will be my answer. So let's quickly try to merge it, and in the process try to find the fourth index element, and in the process try to find the fifth index element, that is index 1 and index 2. So we will not be merging it, and let's call the first index as count 0. Count refers to the first index, which is 0. How did we merge? We started at 1 and we started at 2. Hypothetically think, which one will be your 0th index guy? 1 will be a 0th index guy, right? Let's move to 3, and that means the count moves to first. You're looking for your first index guy, and that's 2. Let's take 2, and now let's move this and move the count to the second index. Now you're looking for your third index guy, whose actions will be similar, so you'll be understanding it. Doesn't matter which language you follow. So what I am doing, after that we know the values of index 2 will be half of the total length, and index 1 will be 1 before that. Simple. And we are keeping the index tracker. This is the tracker. The count is the tracker, which is basically saying, okay, on array 3, this is the index that I'm looking for. Initially, you're looking for 0th index, right? So that's your index tracker. And we haven't figured out the elements, so that can be stored as -1. What I do is, I basically do the same looping, where I try to merge both of them. If for this index tracker count 0, this element is smaller, I go inside and I know array of I is the element that will be present at my current index. And if the index tracker is equivalent to one of my index that I'm looking for, I say, hey, please assign yourself. If my index tracker is equivalent to the other index that I'm looking for, maybe assign yourself. So either of these conditions. And after that, count plus plus, because this index is done. Let's find out the next index and I plus plus. So this is how this one will look like. A similar thing will happen for the else. What if we have taken B? In that case, if we find both, we can stop. Then you pick it up, or else you just keep on moving. Is on the right. If the index tracker is equivalent, you pick up from the right and you keep on moving. Again, the optimizations can be done. If you find index 1 and index 2, like both have been found, you can just break out. You can break out. And instead of -1, probably you have to give int mean or int max something. Such an element which doesn't exist in the array. And then you can simply break out the moment you have figured out